Okay, we're off and running. So welcome. This is Tuesday, October 29th. Let's go ahead and dive on in. Let me just check in. Actually, let me check in first. See if you have any questions on anything so far. Anything we need to review right quick. We're going to do some review of factoring for sure, but kind of want to just check in also if you have any questions that you want addressed on a more urgent basis. And maybe not. That's okay too. So let me know if you have any questions as, oh, let me do my video. Sorry about that. Okay, let's see. There we go. My video is working. Okay, so if you do have any questions, let me know. But the other thing I wanted to kind of go over um, as we prepare for the test tomorrow is, where was it at? Is factoring, and I kind of wanted to go back to one of our lessons here. Let me see, where is it at? Pardon me, I can't see. Oh, here it is. 3.R.7, which is basically a review of factoring techniques. That's the thing that we need to review right quick, um, or just kind of as part of our process. Um, so remember the different types of factoring methods. Remember, you could always look for the greatest common factor. If it's two terms, you look to see if the difference of two squares can apply. If it's three terms, you look for the one of the trinomial methods, the AC method or something like that. And if it's four terms, then you look for the grouping method. So with that in mind, we have four terms here. You would want to, because it's four terms, the one that you would want to look to see if it applies is the grouping method. And so how do we do the grouping method? Just a quick refresher. We're going to group the first two terms together. We're going to group the last two terms together. And in this particular problem, is there anything I have to watch out for whenever I do my grouping? Is there anything I have to watch out for? What would you all say? And particularly with this problem here.
The minus sign in the middle.
Yeah. So keep in mind that when we're putting this parentheses right here, and there's a minus sign, oops, and there's a minus sign in front, well, that we're breaking up the minus sign, we have to be, this is a problem area. So what happens when we have the circumstance, when we have the minus sign right there? What do we have to do to compensate? We take a look at this sign over here in front of the last term, and what do we do with it? Any takers? What do we do with this sign over here?
You flip it to a positive, so you put
Yeah,
a plus.
change it. So if it's a minus, change it to a plus. If it's a plus, change it to a minus. Turn it opposite. That's the thing, and that's what happens when we have this minus sign right here. That's the key. So you only change the sign of the last term when you have a minus sign in front of your third term. Okay, so from here, we got to do some factoring. You look at the parentheses themselves and you ask yourself, hey, is there a common factor I can pull out? And yes, from this one, what would be the common factor I'm going to pull out from these?
Y.
It's the y, yeah. So when I pull a y out, what's left? What's left
The
inside? I'm sorry,
sorry, the x plus 3.
the x plus 3. Bring down the minus sign. Now is there a common factor I can take out of this? Second set of parentheses. Excuse me. What do y'all think? Anything common between 17x plus 51?
17.
Yeah. So keep in mind, when you're factoring, your goal is you hope that you get this. We'll kind of use this as your guide. Okay? That's sort of I hate to call it cheating, but it is kind of cheating, isn't it? You're trying to engineer a result in a way. So here, if we take a look at it, I want to get this thing to be 1, and I want to get this thing to be 3 left behind. Well, what value would that be? Well, basically the 17, we're going to pull the 17 out. So if we pull that 17 out, we get the 1 in front of the x that we need, and hopefully that gives me a 3 left behind. And yes, indeed, when you divide 51 by 17, it indeed gives you 3. So we do have indeed x plus 3 left behind. That's exactly the thing we're looking for. We want the same binomial. So you pull that same binomial out, and so we get what? X plus 3, and then second set of parentheses, the stuff on the outside, the y minus 17. So that's a quick review. This is a good problem. This is something that you could anticipate seeing on the test, certainly 4 terms grouping method. But more in particular, the minus sign here is the thing I would probably throw in to test on just so that you're familiar with it. So this is a good test question, test type question. So let me pause here. Any questions on this one? Okay. So let's go forward. We're going to look at a couple more. We're not going to do too many because we got other things to do. But I do want to do a quick review of the factoring methods. Now, this one again, look at the number of terms. There are 4 terms. So that means we're going to look at the grouping method once again. And so I'm going to kind of leave you to that one to do. Here, this one, it's got the common binomial. So that's the thing you want to pull out. Okay, that's the thing you want to pull out. The common binomial is the thing you want to pull out. So when we do that, in the first set of parentheses is 2x plus 9. What goes inside the second set of parentheses? What goes in here?
Is it what's left out? The 7a to second power minus 4x?
Uh-huh. 7a squared and then minus 4x. That's exactly right. That's it. So this is taking out a GCF, if you will. It's just a binomial. 2x plus 9 is the GCF in that case. So that's also something to be familiar with. And that's part of the grouping method. It's a subset of it. Now here, this is 3 terms. So it's a trinomial. 3 terms, trinomial. You can use, and I always like to reference Addie's note before, because she's right. You can use the AC method here. You can do AC. What's A in this case?
1.
1. So AC, and what's C?
The 24.
24. So we do 1 times 24 gives us the value of 24. So the AC method still does work here. We're implicitly doing it. So what do? You look for the factors of 24 that will add to give your middle value of 10, your middle value of 10. So what are the factors of 24 that will give you your middle value of 10?
6 and 4.
Right. 6 times 4 will give you 24, and they will add to give you 10. That's exactly right. So when I go to factor these, I put my x in the first spot of each, and think of this as positive 6 and positive 4, because the positive gives you the sign in the middle, positive 6 and then positive 4. Helps you to sort of fill it out a little easier. And boom, that's it. Questions on this one? So are you finding these methods, I mean, kind of, how are you all feeling on these factoring methods? Yay, nay?
No problems.
Thumbs up, thumbs down, sideways. My little boy does this. He'll do it sideways. So it's just something that takes practice, but it's important because as you've seen, when you do rational expressions, that's essentially what you're doing is you're just factoring over and over and over again. So this is another trinomial, just like we did in the prior one. Look for the factors of negative 32 that add to give you negative 4. So this one is the more traditional AC method. The more traditional AC method. So what's the value? So let's do the AC method. Let's do it right here. Let's do A, times C. So what's our A value? What's our C value? A value is what?
8.
8. And the C value is what?
-4.
Right. So 8 times -4 is going to give you -32. So you ask yourself, what factors of -32 will add to give you -31? Any takers on that one?
1 and -32.
Yep. 1 times -32. That definitely gives you -32. And when you go to add those, they will give you -31. So we're going to break up this term here. Instead of -31c, we're going to write it as what?
It's going to be 8c squared minus 1c. And then you're going to have negative minus, oh no, actually, shouldn't it be a +1?
Okay.
Because it's a positive one. So 1c.
C, right.
And then minus 32c minus 4.
-4.
And then you group it.
Yeah, you could. Now, what? You could also switch these two terms around so you don't have to worry about your minus sign. Just to give you a heads up. It's okay. You can do that too. So let me switch those around. Because the minus sign sometimes gives me a little headache. I don't like to do it. So I'm going to switch this around to -32c plus 1c. So that my sign in the middle in front of the third term is a plus, not a minus. So I sort of engineered it a little bit. Okay, so grouping method now. Group the first two, group the last two. Good. So when we do that, then we get what? I'll go ahead and do this one. You pull the GCF out of the first set of parentheses here, and that GCF is going to be 8. So I'm going to come down here. 8. Oh, I'm sorry, 8C. Just not just an 8 in the C. Excuse me. Excuse me. Ooh. Okay, pull an 8C out, and I'm left with C minus 4. In front of the second set of parentheses, there's nothing to pull out, nothing common. So you leave it as C minus 4. So I have the same binomial here, which is what I was looking for, hoping for, and I got it. So it's great. So I pulled the C minus 4 out as the common binomial. What's going to go in my second set of parentheses here?
8c plus 1.
Where'd the 1 come from? You're right. It is 8C plus 1, but where did it come from?
Because there's a invisible one in front of the other parentheses.
Boom. Exactly. 8C plus 1. Good. So that's another. This is another good one you'd probably see on your quiz, on your test. Questions on this one? Okay. Let's find one more. Okay, what about this one? So go through your methods. What factoring method uses two terms?
Maybe the sum of the cube, I believe.
Oh, that is the sum of the cube. I'm not doing that one. Skip it. I don't like the sum of the cube. It's not fun.
That
All right,
one wasn't too.
let's do this one.
Oh, squared. Oh, that's not. There's one.
Say it again.
That one is the difference of a square.
Difference of two squares, right? Two terms. So difference of two squares. Potential candidate. We don't know if that applies yet. We have to inspect it. It's definitely two terms, and difference means what in the middle?
You're gonna have a plus and a minus.
Well, we have to know whether the method even applies. So
Oh
because
yeah.
it's possible it doesn't. It could look like it, but not be fully fitting. So we have to go through the steps. Is this a difference of two squares? So you ask yourself, okay, difference, subtraction. Yeah, we have subtraction. Good. Two, yes, we got two terms. Are they squares though? We see an x squared and a y squared, but what about the value of 3 and 27? Are those squares?
No, but you can pull out the greatest common factor in it.
Okay, so that's the other lesson, is always check to see if you can pull out a GCF, because sometimes when you pull out a GCF, you can also then factor it more after that. Right. So in this case, we're going to pull a GCF of 3 out, because the 3 will go into 3 and the 27. So when we do that, we're left with pulling a 3 out gives us x squared, and pulling a 3 out gives us 9y squared. Now we look
And you
at
could
the inside. Does the inside now have the difference of two squares method that's applicable?
yes.
Yeah. Two terms, minus sign, and the x squared and the 9y squared are both perfect squares. So because of that, then, we will do the difference of two squares method. And remember what that is? F minus L times F plus L. Okay? Now we can't forget about the 3 in front. We have to bring that down too. So we put the 3 in front, our two sets of parentheses. What are we going to put as F? What is the F part?
X.
Just a plain old X, right? Because remember, we write this as F squared minus L squared. So what's the L part?
3.
Close. Or maybe it cut out. 3, did you just say 3?
3? Yeah, 3. 3.
More, a little bit more than that.
3y.
3y. Good. So one's plus, one parentheses is plus, one parentheses is minus. Boom. There it is. This is a good test question because of the GCF in front. So I haven't created the test yet, but this is kind of what I'm thinking. Okay, these are all the factoring methods that I'm going to test you on at least. I'm not doing the sum or difference of cubes. I don't like that one. Uh, it almost never comes up. Let's focus on things you'll actually do. Any questions on the factoring methods and what you can sort of expect on the quit test coming up? And just like the last test, it's going to be straightforward. I'm going to test you on stuff that, yeah, I want to see that you know it. I'm not going to throw big old zingers out there. The biggest zinger I'll probably do is like that grouping method with the third term as a minus sign. And maybe a GCF and multiple methods, but that's about it. Okay, questions on anything? Okay. And just like the last time, it'll probably be about closer to 15 questions this time, if only because a lot of the material is a little more straightforward, faster. Um, so it'll be doable in the time period, but a lot of the questions are going to be a little, quicker. So I can cover, and then too, I have to cover a lot more ground on this one. Okay, so to finish up, so just to kind of give you a heads up, the next bit of material, the next test, we're going to have a test in a week from today. Uh, it's going to go through section 1.9. So this is going to be the end of test 3 material, just to give you a heads up. Test 3. And so that's going to be all the way to section 1.9. So that's going to go from section 2.R, here it is. So good. So section 2.R.2 all the way to section 1.9. That's going to be test 3. And that'll be next Wednesday. So you want to make sure that you're done with this bit of material here by Sunday. so that we can do, some review questions on the Monday and Tuesday leading up to it. But you'll see here it's only what, 1, 2, 3, 4, 5, 6, 7, 8, 9 lessons. So I figure about 9 questions, if you will. But it's pretty much just a rehash of factoring, a rehash of radicals, and a rehash of complex numbers. But you're going to be doing it in the context of some of these problems. So we'll take a look at that again, and I'll have a review. I could probably do a review sheet on Thursday. Yeah, I'll start reviewing the stuff on Thursday. So kind of give you a heads up on all that. Okay, so let's do 1.9 right quick. You're going to find it's not terribly challenging. It's just, it's a process more than anything. Process. Okay. So this is a great one to start off with. So what are we dealing with here? And if you take a look at the name of the lesson, it's rational and radical equations. So what does that mean? It means you're going to have an equation, which means equal signs, with rational expressions or radical expressions. In other words, you're going to have this fraction stuff with an equal sign in it. Or you're going to have radicals. Actually, we've already done some radicals with equal signs in them too. We've actually already done a little bit of that. Okay, so let's take a look at how we do this one. Now, let's step back before we actually do this one. Let's actually go back to something we did, a long time ago. Maybe you did. 2/3 x plus 1/6 equals 4. Let me do something like that. How would you solve, this is a review. How would you go about solving this one? Any takers or recollection?
Would you
Let's say it this way. Raise your hand if you like fractions. I probably got no one raised their hand. So if we can, it would be wonderful if we could get rid of the fraction, right? So think of when we look at a fraction like 1/6, what is the operation associated with a fraction?
divide?
Divide. So what's the opposite of divide? Remember what the process is. Do the opposite.
Multiply.
Both sides. Right. So we want to do the opposite of fractions. So we want to do the opposite of division, which means we want to multiply. So we're gonna take a number and we're gonna multiply it to both sides. Okay. The question is what's the number going to be? Well, we want the number to be able to cancel out all those denominators. And the magic number we're going to use is called a what? A common denominator. So basically ask yourself, what value is the common denominator here between these? It doesn't have to be the least common. It just has to be common, okay? So what is a common denominator?
Would you say 3?
Isn't 6 a common
Close.
denominator?
Yeah, it's 6. You got to ask yourself, remember what common denominator means is what value will the two denominators go into? The 3 is what we call the greatest common factor. It's the value that will go into both. So it's a slightly different question. So general rule of thumb, you always look for the values that are higher. So 6 or higher, 6 or higher. So yes, in this case, 6 is the magic value that's going to do it. You take this, you take this term, you multiply by 6, you take this term, and you multiply by 6, and you go over here on the right-hand side and multiply it by 6. So every single term gets multiplied by 6. Because what happens? Those are going to cancel to leave a 2 behind, so that becomes 4x. These are going to cancel to leave the 1 behind. And then on the right side, 4 times 6 is 24. Well, look at that. Fractions are gone. So the moral of the story, the thing to recall from earlier in the course is when you have a fraction, multiply by the common denominator. Okay? And so that sort of begs the question then, how do we build common denominators? How do we build common, and this is what I've sort of been trying to repeat over and over and over again, is the process. You don't really have to know what the common denominator, you just have to know how to build the common denominator. So if I look over here, what is the common denominator? What is a common denominator? What do they, how, and you, all you do is you ask yourself, how are they different? How are they different? So if I look at 7x and 8x, how are they different?
They're different by one number.
One has a 7 and the other one has an 8. But they both have an x, okay? They both have an x. So the way that you build a common denominator then, for this purpose right here, is you just take what is different, multiply them together, and then multiply what is common. Take what's different and then find what's common. And so this gives us what? 56x. 56x. That's the common denominator in this case. So I'm going to take 56x and multiply it to each side. And what's that going to do for us? Well, you look at these two. Do they cancel? How do they cancel? 56x over 7x. Let's go to my scratch sheet of paper. If I'm going to come over here, do 56x over 7x, what's the result? What's 56 over 7?
Is it 8?
8. What happens to the x's?
Do they cancel?
They cancel. So that leaves 8. So these are going to cancel to leave an 8. Now this 8 is going to multiply the entire thing, x minus 2, so we have to put it in parentheses. Bring down the equal sign. So how about 56x and 8x? How do those cancel? Yeah, there you go. So 7 is left, and then put that on the outside of a set of parentheses. So it's multiplying the entire denominator. And there we go. Denominator's gone. Now all of a sudden this turns into a problem like you did all the way back in week 2. All the way back in week 2. So the moral, the lesson right here is that when you have fractions, find a common denominator, and that's what you're going to multiply to both sides of the equal sign. So finishing this one out, now you got to get rid of the parentheses. So distribute that 8 in, distribute that 7 in. So that gives us 8x minus 16 equals 7x plus 7. And just remember your process from this point. I need to subtract 7x from both sides. And I need to do what? Add 16. So that gives me a final answer of x equals 23. So all we're doing is we're taking your rules of finding common denominators and just say of equations with fractions and saying, oh, you got to multiply by the common denominator to get rid of the fraction. That's all we're trying to do. Okay, I see what. That's interesting. Let's do another one. Very similar. So what's the value I'm going to multiply to each side? Look at your two denominators.
Your 5 times 6.
5 times 6. And what else do we have in there?
X.
And an x. You take one of everything. That's actually probably a better way of saying it. Take one of everything. That's how you're going to build your common denominator. Take one of everything. Take a 5, take a 6, and take an x.
So you're going to end up at 30x.
Right. So 30x is the value that we need. 30x. And you know what you can do? A little cheat sheet, if you will. A little cheat sheet. If you really want to cheat sheet it, you can do, oops. You can do, let's take this right here. 5 times 6 times x. What does that get you when you do that? Well, the 5 and the x cancel with the 5 and the x to leave a 6. I mean, that's a way to think about it. I don't know if it helps, but that's
It's almost like cross-multiplying it across.
and
And then you would take,
there's the
you would
magic
take,
phrase. You are cross
yeah.
multiplying. You are in essence cross multiplying.
Does that mean for the other side you would use 5?
Right. There's a reason why I'm not using the phrase cross multiply. It's misleading. It's misleading. So 5 times 6 times x. So take one of everything and do the same thing. 6x, scratch out the 6x, leaving the 5. So on the left side, it's the 6 times x minus 2. Bring down your equals. And then it's the 5 times x plus 3. So I'm going to leave it for you to answer this one to solve on your own. But when you go to do this, you get x equals 27. X equals 27. But the key is finding the common denominator. So when you're talking about fractions like this, you take you look at your denominator and you take one of everything. Take a 5, take a 6, and take an x. But that same sort of idea of take one of everything is going to also help you when you get bigger problems, bigger ones. Now, before I leave, Jackie said, hey, this is like cross multiplying. And she's exactly right. It is cross multiplying. How can you recognize when there's a cross multiplication process? And so basically what does cross multiply mean? You take the numerator of one, multiply with the denominator of the other. So you cross multiply. I don't particularly care for that because cross multiplication is such a special, unique situation. It doesn't work and apply on every problem. We're going to see one in a second where it does not apply. So that's why I don't like to use the phrase cross multiply because it's very misleading. Okay, so let's go forward then. Oh, look, here it is. This one, cross multiplication, does not apply. Does not apply. Why does cross multiplication not apply? Because this left-hand side has two fractions. Cross multiplication won't work on this one. So that's why I don't like to use it. But this was a very good one for that whole notion of one of everything, So I'm going to bring this down. This is z over z minus 3. Then minus 9 z plus 6. Now on the right-hand side, that denominator, this one right here, you got to factor it. When you see a big, you got to use your factoring methods. So using our factoring methods, z squared plus 3z minus 18, that is going to give you z what? Oh, z plus 6 times z minus 3 if you ever get stuck on factoring with these problems, by the way, if you ever get stuck, look over here. That's what it's in the problem. So you can use the problem as your guide if you ever get stuck and say, oh, hey, are one of those it? 9 times out of 10, yes. So what am I going to multiply on both sides? Take one of everything. Look at your denominators. So when I say one of everything in this case, what does that mean? Well, I'm going to take a z minus 3, this thing right here, and I'm going to take a z plus 6. I already have them over here too, so I don't need to take another copy. I just need one copy of each. So my common denominator in this case would be z minus 3. I'm just going to write the z like that. And z plus 6. Okay, so I'm going to multiply that to the entire left side, and I'm also going to multiply it to the right side. Z minus 3. It's supposed to be a z, not a 2. But my handwriting's so poor that it looks like the same. So you multiply that thing to both sides. So let me pause here. Do you all see how I got this thing over here of z minus 3 times z plus 6? Do y'all see how I got that? Any questions on that? So we had to first factor the denominator up here, factor this denominator up here, and then you have to find or take one of everything from the bottom. So what do I do now? We'll basically just look at this first fraction has a z minus 3, so it'll cancel with it to leave a z plus 6. Do y'all see that? So I take the z here in the top and I multiply it or put it on the outside of the z plus 6 that's left behind. Bring down this minus sign and do the same thing. I have a z plus 6 here that's going to cancel with this, leaving a z minus 3. So I take my 9 here and I put it on the outside of a what? A z minus 3. So essentially, if you notice, whatever the denominator didn't have, that's what I'm going to multiply the numerator by. That's the missing factor. And then on the right side, let me get you all involved with this. What does
Where
this
did you get
simplify
the 3
to?
from?
Wait, let's go back.
I was going to say, where did you get the 3 from? I get everything
one?
up to that 3.
So remember, I'm taking this thing right here and I'm multiplying it to this. So I cancel the z plus 6 to leave me a z minus 3.
Okay, I get it now. Thank you.
So what about over here? What happens?
Would they both cancel it out?
They both cancel. This z minus 3 here cancels with this z minus 3, and this z plus 6 here cancels with this z plus 6, leaving, there's no more denominator, leaving just the z squared. Do y'all see that? No more fraction, but now we got some more work to do, don't we? What do we have to do now? You got to get rid of your parentheses. Now you got to actually go through the rest of your process like you did back in the past. Get rid of your parentheses, combine your like terms, get variables to one side, numbers to the other, just like you normally would. So I'm gonna pull this off right quick because I'm running out of space.
You're going to distribute first?
We're gonna continue the problem. So we continue the problem. Let me actually type it, probably a little easier. So when I do it, I get z times z plus 6 minus 9 times z minus 3 equals z squared. So, right, you got to get rid of the parentheses, which means apply the distributive property. So we're going to z times z, z times 6 gives us what?
Z squared plus 6z.
Right. And then we do the negative 9 times z, negative 9 times negative 3 gives us minus 9z plus 27. And then just bring down the right-hand side. Now what?
Grouping method.
Well, let's clean it up first. Remember what we're trying to do. And when this actually goes back to something. First, let's clean it up. Let's clean it up. We can combine those like terms, can't we?
Yeah.
So what happens when we combine like terms?
You get a trinomial.
So we get z squared, 6z minus 9z is minus 3z. Bring down the 27. And the right side is still the z squared, okay? Now remember, a couple lessons ago, when you have a square, what do you want to do? You want to apply, well, this is what we call a what? A quadratic. What was the method for doing a quadratic equation? Get the right side equal to what?
The left side.
Equal to 0.
0.
Remember when you apply the quadratic method, when you apply the factoring method, you got to get that right side equal to 0. So essentially, you got to shift everything when you're dealing with quadratics. And how do you know if you're dealing with a quadratic? The square. That's the giveaway every single time. So we need to get this thing here and put it over there. How do we do that?
So you're going to subtract it.
We're going to subtract what? Z squared.
Z squared from z squared, which equals up as 0.
Oh,
right?
Thank goodness. It kind of all worked out, didn't it? Because
Yeah.
this is going to go away. Oops. This
So
is
then you
going
have
to
a
go
binomial.
away. And this is going to go away to leave what?
A binomial? Or difference of two squares, most likely. Well, no, you can't square it.
Well, z squared minus z squared. Let me do this.
No, you're
So
left
this
with
can't-
negative 3z plus 27, right?
Those go away. Those go away. Right. So minus 3z plus 27 equals what? What does this right side simplify?
0.
0.
Boom. Exactly. 0. That's what we wanted. We had to do it. So notice now, what we thought was going to be quadratic, the whole purpose of all this, of moving the z squared, is because we thought it was going to be quadratic because we had z squared. That's the giveaway. So when you have a quadratic, you got to get the right side equal to 0. But when we did that in this case, it happened to work itself out because the z squares canceled, leaving something we were doing all the way back in the second week of the course, solving regular equations. And so now you got to fall back to that other process all the way back, 6 weeks ago now, 7 weeks ago. Okay, this is an equation. I got to do what? How am I going to solve for z now? Shifting gears.
You bring the 27 over to the right side.
I subtract 27 from both sides. So now let me come over here because I'm running out of space. So that leaves me what? Negative 3z equals negative
9.
27. and then divide both sides by that -3. Leaving me the final answer of z equals 9. So you have to be prepared. You have to remember a couple weeks ago, or just last week, I mean, when you have the square, it's quadratic. So you have to apply your quadratic methods, which means fundamentally you got to get the right side equal to 0. Now in this case, the z-squares happen to cancel with each other, go away. So when that happens, you got to fall back to your other method and say, oh, wait, when I have just a plain old z or a plain old x or a plain old y, oh, that's all the way back. I got to undo and move things back over. So that's why we had to shift gears. We thought we were going to do quadratics, but the problem, did a head fake on us. And we had to kind of sort of remember, our original solving equation. So the gist of this all, you're getting to a point in the session now where you're having to remember all the stuff you've done over the past 6-7 weeks. Fundamentally, this is kind of like a final exam, if you will, because everything's coming at you all at once. You got to be ready for it, is what I'm saying. Okay, before we leave this problem, this is our solution, okay? This is our solution. Before you submit your final answer, you got to go back to the original problem. Does it make is it a permissible solution? Is z equal 9 a permissible solution? In other words, it's permissible if so long as it doesn't make any of the denominators become 0. If it makes even one of the denominators 0, impermissible. We can't have it. So remember the notion of restricted value we talked about yesterday? What are the values that are going to make these denominators 0? So will 9 make this one 0? No, it's fine. Will 9 make this one 0? No, it's fine. And this happens just to be the same thing. So it's fine. The 9 works. It is okay. Thumbs up. But you have to be on guard for that. And these types of problems where you have variables in the denominators and you're wanting to solve, you always have to ask yourself, okay, I got a value. Is it permissible? And they're going to throw you a zinger, and sometimes it's not going to be permissible. So you just have to be on guard for it. Oh, and here's one. What's the giveaway, by the way? This lets you know you have to be on guard for it. It is possible that you get a value that is no solution. It is possible to get a value that is no solution. So in this one, by the way, what is the common denominator we're going to be using?
-3x.
Use the entire thing.
Oh,
So,
it's just 3x.
not just 3x. Well, 3x means what? 3 times x. What's going on with the 3 and the x here? Subtraction. That's a different operation. So you want to keep it as the unit x minus 3. So x minus 3 and what? X minus 1. Okay? That didn't come out well. That's what you're going to multiply. And you're going to multiply it to every single term. To every single term. And we got to do it to the right side too. So what happens then? So this x minus 1 here is going to cancel with this x minus 1, leaving the x minus 3. Ugh, nards. pardon me, I kind of erased a couple things. Okay, so what does that leave? The 2x from the top, 2x from the top, multiplying the x minus 3 that's left behind. Okay? So 2x times x minus 3. Now how about this part right here? Well, that x minus 3 is going to cancel with that, leaving the x minus 1 and the 2. And the right side? Do we cancel anything on the right side? No, because there's no fraction. So this just becomes 2 times x minus 3 times x minus 1. So do y'all see how I get this right here? Essentially what happens is once you find the common denominator, you essentially take the top and multiply by whatever thing isn't in the in its denominator already. So this one here, this was a 2x, had an x minus 1 in it. So I multiply by the other thing. And similarly, this 2 here had an x minus 3. So I multiply it. I multiply that 2 by the other part of it, other part of the common denominator. So you're left with this big long thing, and so now you got to go ahead and get rid of the parentheses. You got to apply your FOIL method, your distributive property, things of that nature. So I'll go ahead and do this part. So this becomes 2x squared minus 3x plus 2x minus 2. And on the right side, I'm going to do FOIL method first. X squared minus 4x minus 3. And now I can go ahead and multiply this by 2, multiply the 2 on the outside into each term on the parentheses, and so that becomes 2x squared minus 8x minus 6.
I have a question.
Uh-huh.
At the very beginning with your 2x, I get 2x squared, but 2 times 3 is not 3x, is it?
Oh no, it's not, it's 6x.
Okay.
I'm going to get rid of that. Thank you. Let me come over here. So 2x squared minus, proper now, 6x plus 2x minus 2. And then this one we had 2x squared minus 8x minus 6. Okay, just like before, we see the squares. We should be thinking quadratic. So I need to get those squares over to the left side. So to do that, I subtract 2x squared from each side. Okay, so well, let me do this. It's not going to. So I'm going to subtract 2x squared from each side, and what happens? Lucky us, they cancel. Okay, leaving the rest of it. Leaving the rest of it. So I can clean this part up. Minus 6x plus 2 is minus 4x. Then bring down the minus 2. Bring this part down, minus 8x. Minus 6, by a whole lot of minus signs. And now you solve equations like you normally do. Move the 8x over to the left, move the 2 over to the right. And when we do that, we get what? 4x
Plus.
equals negative 4. And when we solve that, we get x equals negative 1. And the only thing we have to do is we have to check. does it make either of the denominators become 0? No, it's fine. So the solution would be -1.
Are you sure you did the other half of the thing correct? Because 2 distributed into x isn't 2x squared, it's just 2x for the other side, isn't it?
Over here?
Yeah, that wouldn't be a 2x squared, that would be 2x, right? You distribute?
Well, yeah, but apply FOIL over here.
Okay, that's what I wanted to know.
Yeah. So this part, when we did FOIL, gave us x squared minus 4x. Ah, I have another error. Plus 3.
That's why I was like, something's off.
I do have an error. It's this thing right here. That's my error. I'm not going to... And so then you did the 2 on the outside. And that's where our 2x squared comes in. Right
Okay.
here. So I do have a mistake. Calculation mistake. It's always a calculation with me. That becomes a positive 6 right there. So
It's the simple arithmetic that'll get you.
So this becomes, the only thing that's changes, so it becomes plus 6. So when I add 2 to both sides, it gives me 8. Leaving me an answer of 2. Whew. Not that big of a mistake, thank God. So the answer is 2, and fortunately it doesn't make either of the denominators 0. So that's our answer. The lesson here is when you got denominators, you want to use those denominators. So notice we didn't use 3x. We used x minus 3 and x minus 1. Take the denominators as they are, and that's what you're going to multiply everything by. This is the key to the whole thing. The x minus 3 times x minus 1 to clear out the denominators. That's the first key, I should say. And so you have to use the denominators as they are. X minus 3, x minus 1. Questions on that one? Once you finish this lesson, you're almost done with the really big problems, fortunately. Okay, so now this one here is sort of like, if you remember the thing we did a couple last Thursday, that's the WebEx. It won't process, so I don't have a copy of it. But this is the one when we had the square root. What was our process? How did we get rid of the square root? Do y'all remember? What's the opposite
We
of square
square
root?
it.
Yeah.
Square
We
it.
square it.
You do, it's the same thing. Do the opposite. Do the opposite. With when we had rational expressions, when we had fractions, do the opposites multiplied by the fraction. When you have a square root, do the opposite means square. Now, before we can square though, you can only square when you have this square root by itself. That's the only time you can square. So what that means is we have to get this thing to the other side. So how are we going to do that?
Plus y.
We're going to plus a y. That's exactly it. So let's bring down the 160 plus 40y. Now that's all inside of a square root symbol, by the way. And we're going to add y to each side. So this is what we get. We get y plus 14 on the right side. Now we square. And what does that mean? It means we take the entire left side and we square it. And you take the entire right side and you square it. Now the left side, this square is going to cancel with the square root. The square and the square root will cancel, leaving, basically you just take what's inside and you pop it out. You take what's inside and you pop it out. So 160 plus 40y. How about the right side here? The y plus 14 squared. Well, for that, I mean, a couple different ways you go about it, but fundamentally, you can apply FOIL, you can apply your perfect square trinomial, whichever way you want to kind of think about this, your choice. And when we do that, we get y squared plus 28y plus 169. Nope,
196.
196. Thank you. See? Don't let me do math. Okay.
Where's that coming from? Is I guess my instinct would be to just apply the square to the y and the 4. So I would have gotten like y squared plus 28. But I'm not quite sure where the 28y is coming from.
Let's do a review. Well, if I told you 5 squared, what is 5 squared? How do you translate 5 squared? We know it's 20, we know it's 25. We know it's 25, but how do you get the 25?
5 times 5.
You take the square means take the copy,
Right.
multiply with itself. Okay. So
Thank you.
with that in mind, keep in mind that y plus 14 squared is what?
Y plus 14 times y plus 14. Yeah, I was distributing the exponent instead of foiling. That was
And the reason why you can't do that is because of this guy right there. That plus sign kills it.
got it. Thank you.
Okay. So now that so we're over here. What do we do? What do we do? You see the quadratic, the square term. That's the quadratic term.
You bring 28 over to your left side, correct?
Yeah, you could. So the rule is you get one side equal to 0. And I've always been telling you, and I think Alyssa, is that Alyssa? Allison. Allison's, she's repeating exactly what I said. Get the right side equal to 0. Game plan it. If your y over here is already positive, get the left side equal to 0. It doesn't matter if it's left or right. You can get either side equal to 0. You just need to get one of the sides equal to 0. So I'm going to game plan it. Because my y squared is already positive on that side, I want to keep it positive because personally, I hate negatives. If you've seen, I do a bad job with negatives. So if I'm going to get everything, I'm going to move all this stuff to the other side, to the right side, to get one side equal to 0. That's my goal. Okay. It can be the left side or the right side, whichever one is favorable to you. So if I'm going to get this stuff over, if I'm going to get the left side equal to 0, how am I going to do that?
Y squared is going to stay the same. Then 40 is going to be minus 40.
Minus 40y.
Y. And then 160 would be minus 160 underneath the 190.
You add the opposite. Great. So I'm going to subtract 40y from both sides. And I'm going to subtract 160 from both sides. Excellent. So that makes my left side become 0 because these things go away. They cancel. That's by design. Over here, the y squared comes down. 28y minus 40y gives us what?
Negative 12 minus 12.
Y, yep. And then positive 196 minus 160.
36.
36. Positive 36. Okay. So we've got this now. How do we solve this?
Do you want to factor it?
Combine.
It's tempting to want to combine. Can we combine those two terms right there?
No,
Yeah.
we
Who
can't
said no?
because one squared. One of them's squared and one of them's just a y. So
Right.
you can't add them together.
They're not like terms. They have to be, the y's are different. They both have y's, but one of them's a y squared. A little different.
We can distribute or no?
Not distribute. Distribute means you have parentheses. Remember, distribute means you're trying to get rid of parentheses. We don't have parentheses. So what's the
So
method here? So
this is a trinomial.
so we have to, so that, remember, this is a quadratic equation.
Yeah.
How do I know it's a quadratic equation? What's the giveaway?
It has three different.
The square over the y.
The square over the y. And so this is a quick refresher. The square over the y tells you it's a quadratic equation. So there are two methods. You can either use the factoring method or the quadratic formula. Okay? So if it factors, so you can use the factoring method if this thing here factors. If it doesn't factor, you have to use the quadratic formula. So the question, so that's the $1,000,000 question now. Does this left-hand side factor? I'm sorry, right-hand side. Does the right-hand side factor?
We have to try the method first to see if it factors, and if it doesn't work, then we have to go back and do quadratic.
Exactly. You got to try
Okay.
your you got to try your methods. Now, you don't have to factor it if you don't want to. You can use the quadratic formula on every quadratic equation. It will always work for every one of them. So if you don't like factoring, move on to the quadratic formula. Remember what that is? Minus b plus or minus the square root of 4. No, b squared minus 4ac. All of that. You can all of that over 2a. You can do that if you want, and it's just the order of operations, PEMDAS. But this one here does indeed factor. It becomes y minus 6 times y minus 6.
So then it would be, can you put y minus 6 squared as an answer?
No, because remember what we're trying to do. Once you factor it, you set each individual factor equal to 0.
I see what you're saying. Okay.
So that gives us what? The final answers become y equals 6, and then this one is also y equals 6. So that's the same, it's the same one. We call that a double root, or a repeated root. It's the same value twice as the solution. Okay, good. Okay. So that's the answer, is 6. Y equals 6. But notice the key here is and this is actually a problem we already did once before in a previous section, actually last Thursday's lesson. But it goes back to the fundamental thing we talked about way back 6 weeks ago. When you see the word solve, that's 2 steps, 2 general steps. Do the opposite and do it to both sides. You just have to ask yourself, what's the opposite? What is the opposite thing? What is the thing I'm doing, and what's its opposite? Here, we got a square root. Its opposite is squaring. In the prior problem, when we had fractions, that's division. The opposite is multiplication. So you just have to assess, what is the problem giving me, and what is the opposite of what I'm trying to do here? Excuse me, my nose all of a sudden. Questions on this one? And when you want to apply the square to each side, you have to get that over to the right side. Why? Just as a quick refresher and reminder, when you square each side, you can only do that when you have the square root part by itself on one side. So let's see another one. Let's see another one. I'm sure they're going to give us another one here. Okay. By the way, when you're in Hawks, you see 2 blanks. They're telling you it's 2 answers, 2 numbers. And if you see 2 blanks, that traditionally means you're going to be having a quadratic, because quadratics give you 2 solutions. Okay, so you could use the format to help guide you as to kind of what do you think the process is going to be. So again, we have a square root. So we want to apply the opposite, which is to square both sides. But before we can do that, what do we got to do?
You gotta move your, add your y to the other side like the other one.
We're going to get rid of this y, move it over, and we're going to do that by adding y to each side. Okay? Adding y to each side. So when we do that, we get the square root of 49 minus y. And on the right side, it becomes y plus 7. Now what?
Now you have to put them in parentheses and square them both off.
Square each side. Exactly, yeah. And I like the way that Jackie said it too. So it's a reminder. I didn't say it, but it's a good reminder. Put the entire left side inside parentheses. Put the entire right side inside parentheses so that you know what you're squaring. So when I do the square on the left side, what does it become?
It's just 49 minus y.
Right. The square, the exponent of 2 cancels with the square root symbol. What about the right side? Y plus 7 to the second power.
It's y squared. So you got to FOIL.
FOIL. Remember, so that come over here, scratch sheet of paper, y plus 7. Remember, this translates to y plus 7 times y plus 7. So when we do the FOIL method on this, you will get, I'm going to come over here now, you will get y squared plus 14y plus 49. Funny. Now what?
Now you want to take your stuff from your left side and move it over to your right side if you can.
What's your goal in doing that, Jackie? Why are you doing that?
To make a 0 on your left side.
And why? And so then, more wise. I'm like a 2-year-old. Why are you getting your left side equal to 0? How did
Because
you
then
know to do that?
Honestly, because I'm following the one right above it, step by step. But
Anybody else? What's the giveaway? What's the giveaway that we need to get one of the sides equal to 0?
The square.
Right. This term
Okay.
right here. That's the
Yeah.
quadratic term. When you see a quadratic term, alarm bell should be going off saying quadratic, squared. I need to get one side equal to 0 because I'm either going to do the factoring method or the quadratic formula, and in order to apply those, I need one side equal to 0. So it's that y squared term at this juncture that tells me, I got to get one side equal to 0. Excuse me. So I am going to indeed move, as Jackie recommended. I'm going to take this 49 minus y. I'm going to shift it over to the left, but I can't just shift it. I got to do what? I got to add the opposite.
So you have to subtract 49 from the other 49, so that cancels out later. And then you need to add y to the other side. Now I have a question. When you add y, you don't add it to y squared. You have to add it to the 14y because you would assume that it has a 1 in front of it, right?
I am going to add y here.
Yeah.
But why? It's because, let me ask, can I add those?
I would feel like you would be able to, but you can't. I know
The
you
answer
can't.
is no, because they're not like terms. They're not like terms.
Now, whenever you add y to the 14y, do you get 14y squared?
14 apples plus one more apple gives you how many apples?
Oh, never mind.
15 apples.
Yeah.
Combining like terms. So think about it this way. When you're adding and subtracting terms, like terms, you can combine like with like, okay? That's where the notion of like terms comes into play, when you add or subtract terms. Does that?
Mm-hmm.
Yeah, it's just, this is where you're getting flooded. Now what you're having is, kind of think of it kind of like an amnesiac. When they start remembering everything, what happens? They're flooded with everything. This is what's happening to you at this stage, is everything is coming back to be applied. Like terms, distributed property, FOIL, all this junk from the past 6 weeks, flooding in to all these problems. Okay, So we've got this. 0 equals y squared plus 15y. What next? Alarm bell should be going off. This is a quadratic. So what are the two methods for a quadratic? I can either, because it's a quadratic equation, I can either do a factoring method if it's factorable, or the quadratic formula. Is this thing factorable? Is this thing
Yes.
factorable?
I know your 15 can't be squared, so I know it's like not like that. So I would do the quadratic formula.
Anybody else? What about a GCF?
You pull out y.
Could pull out a y. Happens to be factorable. They won't always be factorable, but go through your methods. Two terms, difference of two squares, and it doesn't work because there's not a minus sign. Oh, but wait, GCF. I always have to look for a GCF. And yes, there is indeed a common factor you can pull out. So it is factorable, happens to be factorable. If you did quadratic method, perfectly fine too, you get the same result. So now that you have it factored, okay, I'm gonna come over here, get rid of some of this stuff. So now that it is factorable, you set each factor equal to 0. And so what does that give you for your solutions? Well, this one's already solved for y. And then this one becomes what?
Negative 15.
Negative 15. Those are your two solutions. And good, we got two blanks. You can't say I kind of wrote over them, but here are the two blanks. That's where they will go. It's all flooding in. Everything that you've learned over the last 6 weeks coming into play. And that's sort of a bummer about it, but you know, it's a good prep for the final exam, which you're going to have what, in a month. So it's just getting you ready for all that. Questions on this one?
Are we taking a midterm?
I don't think I have a midterm. I just did like 4 tests.
Okay.
This is essentially a midterm if you want to think of it that way. I mean, it applies to almost everything that you've done.
To the midpoint.
Say it again.
To the midpoint of what we're learning.
Yeah, I think midterm was actually what, a week or 2 ago. So
I didn't know if it was for the shorter classes because I know for the longer ones they do. So we're 4 weeks shorter.
yeah, I just tend to do this one was such a long unit. I did two tests instead of one.
Are we your only class?
Say it again.
Are we your only class?
Oh yeah, that's why it's 4 nights a week. Okay, so the rest of the problems here pretty much run the same way. Okay, you know, you're going to be look at this. So you're going to apply your rational. This is a rational. When you say rational, it's fractions because it's a ratio. Ratio means a fraction. So you want to get your common denominator. Really, there's nothing new now. This one here, this is a little different. How would you go about doing this one? It's okay if you don't know. I'm going to tell you. The giveaway here. Go ahead.
Oh, never mind. I thought you could square them out, but they have a 3 in either one of them. So I don't know.
They have a 3, right? So the cool thing here is this side is already 0. So remember what we said is if you're going to square something, if you're going to undo a radical, you got to get this thing by itself on one side. You can only have one radical on one side. So why don't we take this one here and move it over? Can we do that? Yeah, nothing wrong with it at all. How would we do that? Well, we would add the opposite. So we will add the cube root of 7y plus 16. Plus 16. And we're going to do it to both sides. So add the cube root of 7, 7y. It's supposed to be a 7 there. So you just add it to both sides. So when we do that, what do we get? Well, on the left side is that cube root of 20 minus 3y. It's supposed to be a 0 minus 3y. On the right side is that cube root of 7y plus 16. Fortunately, they both have the same root. What's the root?
3
3.
cubed.
How are you going to undo a cube root?
Would you just do it by 3 whenever you put it in parentheses?
Whatever the root is, that's what the exponent's got to be. So to undo a square root, that's why we square both sides. To undo a cube root, you raise both sides to the third power. That may make you a little nervous, like how in the world am I going to do a cube root? But the nervousness goes away real quick because why? Remember, this exponent cancels with this root. It cancels with the root. So what happens?
So you just end up with a problem and you have 20 minus 3y on one side and then 7y plus 16 on the other.
Basically, you just pop out the stuff that's on the inside. It pops out, leaving you exactly 20 minus 3y equals 7y plus 16. So the craziness goes away. The craziness goes away. The crazy part of the problem goes away, I should say. So what do we get as our final answer? Well, that's interesting.
So you have to solve it, right?
Solve it right. Really? Do they mean to do that? I guess so.
Go to tutor and see what steps they want you to take too.
Yeah, just more, it's a fraction as an answer. 2/5.
Oh.
2/5. I think it was just sort of a typo. Oh well, it is what it is. 10. Yeah, it's 2/5. 2/5. It's 4/10, which reduces down to 2/5. Okay, so really nothing more new here. It's just the same thing, old hat. Practice with this, but just keep in mind whenever you see the phrase solve, remember that's your 2 steps. Do the opposite, do it to both sides. And now that becomes much more of a fuller statement. You got to identify what does that mean? What do I have? How do I apply the opposite? Things of that nature. Let me pause here. Any questions on this one? So you're going to get this lesson here, this 1.9 sort of rounds out and sort of completes the tale in terms of this sort of this first half, but you're just bombarded with everything. So this lesson, whoops, here it is. This sort of grouping of stuff from here down to here is really just it requires everything of you. Distributive property, combined like terms, order of operations, rules of exponents, that's the quotient rule, the product rule, the negative exponent rule, power rule, like that. Your clock with your complex numbers, quadratic formula, factoring, it brings it all together. Brings it all together. Rules of fractions, I can see that now too. So it really just brings it all together. And so let me pause here. Any questions on any of that? I mean, you do it. And so when you go to do this stuff, have this stuff done by Sunday. This Sunday, whatever that is. What is that, November 3rd? November 3rd. That way, the test is only a couple days later. It'll still be sort of fresh for you. And we'll start doing some review. Tomorrow we'll do some review. It's going to be really a lot of old hat, factoring, quadratic formula. It sounds like what we need to review is the quadratic formula, the quadratic stuff, and the
Not
radical.
tomorrow.
Mhm.
Tomorrow we have our test, and you don't have class.
Right. So Thursday. Oh yeah, thank you. Thursday we'll start the review.
You didn't make the test yet,
Upload
did
the
you?
test
I
tonight.
have not made the test yet. You'll see it appear tonight. I'll make it tonight.
Okay, good. I'm gonna take it tomorrow.
Right. And you can take it anytime tomorrow you want.
Thank you.
Okay. So then we have about 5 minutes left, but we can start looking at this other thing here, formulas and geometry, because it's not too terrible. Formulas and geometry, you kind of already have experience with in a lot of ways. So let me set you up a little bit here. This
Is that
stuff's
like
a new sort of unit, and this stuff here is going to rely mostly upon order of operations and the solving equations that we did early in the course. So, but what this first part of the lesson, it really is formulas and geometry. And if you ever don't know what a formula that you need, just you can Google it. You can Google it. What is the formula for the perimeter of a rectangle? Google it and you'll get the formula. The perimeter is 2 times the length plus 2 times the width. So if you ever get stuck, look at the words in the formula, in the problem, to tell you what are you looking for, perimeter or area, and what's the shape? What's the shape? So you have to recognize what the shape is, okay, more than anything. So in this particular one, we want the perimeter of a rectangle, so that's 2 times the length plus 2 times the width. It tells you the length, it tells you the width. So this is your L, and this is your W.
it's 36 plus 26?
So plug in your 18 for the
62?
L, right, and plug in your 13 for the W. And from here, what do you apply?
Distribute or
Your order of operations. Because all you're doing is you're simplifying this side. So it's 2 times 18 is 36. 2 times 13 is 26. Do the addition and we get what?
62.
62. That's what goes right here, 62. Compared to what we've been doing, not so bad. It feels like it should be harder, right? Because at this point in the session, you're doing a much more challenging problems. And so this feels sort of kind of like a reversion back. It feels like we're going backwards. And not that we are, but what we're doing is we're taking the old stuff and we're just applying it in a different context. So let's continue forward here just a little bit. We got a couple more minutes. So take a look at the problem. It says find the area of a rectangle. What's the formula for the area of a rectangle?
Left time width.
Area equals length times width. So it wants us to find the area, so we don't know what the A is. That's what we're trying to find. What's my length? What's my width?
Your length is 16 and and then your width would be 11. Does it really matter, honestly?
Let me poll the class. What do you think? Does it matter? Could this be my width and this be my length?
Either
No.
when you multiply by
Generally speaking, we like our width to be the smaller number and our length to be the bigger number, or it doesn't matter, is what I'm saying. At the end of the day, it doesn't matter. What you call your length or your width, it doesn't matter. So you can call this your length and this your width, or you can call this your width and this your length. You're gonna get the same thing. You're gonna get
it's like
the
a
same
dish,
thing.
right? Like addition, you can do whichever, it doesn't matter what order, but when it comes to division or subtraction, you have to have specifics, right?
Right.
Okay.
So this becomes area equals 16 times 11, which is, I don't know.
176.
Thank you very much. And that's the answer right there. So hopefully you're seeing it's just a matter of the trick here with these is identifying the formula, the shape and which formula you need for that shape. Because every shape has its own formula. Area of a square or a rectangle is different from the area of a triangle. So you have to know what the shape is that you're dealing with. So here, what are we doing here? So we want to find the area of this entire figure. So before we dive into it, what's the figure?
It looks
Certainly
like
looks
a
like
cone.
a triangle with a semicircle, right?
Ice cream cone.
An ice cream cone. Could be, yeah, it could be that. Uh, so, but the takeaway, the lesson here for this one, an ice cream cone is a three-dimensional shape. So here, let me give you a quick tip, by the way. When you're dealing with perimeter, that's one dimension. You're moving in one space. Area is looking for stuff on the inside of a two-dimensional object. And volume is looking on the inside of a three-dimensional object. A cone, an ice cream cone, is a three-dimensional object. So here, when you have something like this, notice this is really the joining of two shapes. This is a triangle, and this thing up here is a half circle. So the way that we're going to go about doing this one is that the total area is the area of the, oops, well, is what? I'm going to do this. The area of the triangle joined with, added to, the area of the half circle. And do you have to write it like this? No. We could have just as easily done this, and probably this is a little better now I'm thinking of it. The area is the area of the triangle plus the area of the half circle. Okay? So come over here to your scratch sheet of paper. Let's find the area of the triangle. So I'm going to come over here and find the area of the triangle. What's the formula for the area of a triangle?
Length time width.
Close. One half times the base times the height, which is the same thing as one half times the length times the width. So in our triangular shape here, what's the base and what's the height?
The base would be 5.4, correct?
So height, think of height like true height. Oh, it's dark in here, you can't see me. This is the height. The vertical, usually what we say is the vertical. This is the height, and this thing here is the base. Think of it kind of like the base is what you sit on, okay? And the height projects is how tall you are. At the end of the day, it doesn't matter which one you call B and H. So, but the base is the 12.7, and the height is the 5.4. So now do your multiplication. Calculator time. 1/2 times 12.7 times 5.4. And this gives us 34.29. Now this is the area of the triangle part. Okay, so we're going to fill in our gap here. Now we need to find the area of a circle, of the half circle. What's the formula for the area of a circle?
What's the formula for areas?
And so you know what? Google it if you ever forget, and you'll find that it's pi r squared. Now, This is the area for a full circle. Full circle. What we have here is a half circle. So what do we have to do to it? Cut it in half. So a half of a circle is half pi r squared. Now fill in your values. 1/2 times pi. What's the r represent? What does r represent in a circle?
The radius.
Okay, and what's our radius here? Let me turn on my light. What's the radius? What does it mean to be a radius?
Like the whole around, all around.
So yeah, this is the review. This is where the lesson is. The radius, so think if we had a full circle here, okay? The radius is the distance from the center to the edge of the circle. So in this particular figure, what does that work out to become? 1/2 of this 12.7.
6.35.
Right. So the radius in this case, we have to take, so the radius, the distance across the circle, across the center of the circle is called the diameter. The radius is half of that, half of the distance from the center to the edge. So we take 1/2 of that 12.7, and Allison, what'd you say it was?
6.35.
6.35. And that's the value we're going to square. So now you apply the order of operations to this. And you can use, it's telling you for pi, use 3.14. So what do we get? So this becomes area equals, I'm going to turn this into 0.5, 1/2. I'm going to turn pi into 3.14, and then 6.35 squared, do on your calculator, is
0.32.
Carry it all, 3225. Don't drop anything yet. Round at the end. And now we multiply. This gives me 63.31. That's the area of the half circle. That's funny. So now we add these two shapes, the area of those two shapes. $97.6. So the lesson with this one is when you have a weird shape like this, it usually is two different shapes being joined together. And when you hear the word join, you should be thinking addition. A half a circle added to a triangle. So let that be your guide. That's how you're going to determine what you do. Is this shape is a triangle plus a half a circle. So that's how that sort of was our guide to the whole thing. And fundamentally, at the end of the day, the two lessons after that is identify this shape in the formula, and then use your order of operations to help you combine it. So really, at the end of the day, all this applies is your order of operations. It's just trying to piece it all. Essentially, what you're doing is you're doing a puzzle. You're doing a puzzle. What do you have? A half a circle plus a triangle. So find the area of your half circle, find your area of your triangle, and bring the two back together. I'm sure your mind is probably mush at this point. We've done a lot tonight. So we'll pick up here on Thursday. We'll start with this one and we'll kind of keep pushing forward, okay? But you know enough to be able to start doing it if you want when we get there. But you're in good shape. Okay, so I kept you over. Apologies again on that. Hope you have a good night. You'll see the test later tonight when I make it. But anywho, good luck. You're going to do fine on the test. Don't sweat it. You're going you know this stuff. It's just a matter of it's all coming together for you now. Okay.
Thank
So,
you.
send me if you have any.
Thank
Let me know if you have any
All
questions. I'll be
right.
happy to help
Thank
out.
you.
Can I ask a question?
Uh-huh.
How is the final gonna work?
Probably similar to what the quizzes are.
Okay.
Uh,
It'll be through Hawks as well?
It'll be through Hawks, right? Exactly.
Okay.
All right. But
Thank you.
it'll be cumulative. But you're already ready for that because these two tests are really cumulative tests already. So we're already preparing you for the final exam by the nature of the problems we're doing.
Okay.
Okay?
All right. Thank you.
All righty. All right, everyone. Hope you have a good night. All right. Bye-bye.